9.2 goes a little further into the function notation, so just to kind of plugging in numbers. So here we have f of x is x squared plus 2x minus 1. We already discussed that anytime I put a number in place of that x, then we basically plug it in for all of the x's in the function. So that this becomes 4 squared plus 2 times 4 minus 1. So then we can solve that f of 4 is equal to 16 plus 8 minus 1, 24 minus 1, f of 4 is equal to 23. Why do we have function notation? Because it really doesn't seem terribly practical, I think, for most of us at this point. Well, you can blame the scientists. I always like to say that because they have to plug in numbers and they're looking for results. And a lot of times in algebra, when we finally get the result, we're like, well, what did I plug in? Well, you've got to go through like pages and pages of formulas, which is not terribly practical. So what does function notation do for us, right? First of all, we don't solve for this f. This does not mean f times 4, okay? It means f of 4 is 23. What is the x value we plugged in? I don't have to go back and figure that out. I carried it with me the whole time. What is the y value? What's the result? That is the 23. So the 23 is the function of the 4 of x, okay? So our ordered pair is going to be the x, which we drag down with us, comma, the function of 4 with the y value, which is 23. So it's a way of kind of keeping track of the x's, whatever we plugged in, as we go. G of x is 5x plus 6. What is g of 5? Well, that 5 will go in place of the x. So it becomes 5 times the 5 plus 6. G of 5 is 25 plus 6. G of 5 is equal to 31. Do not solve for g. This is the point. The x value we plugged in was 5. The y value, or the f of x value we got out, was 31. What is g of n plus 2? Well, that's a little crazy, but we do plug functions into functions. So this time that n plus 2 will go in place of the x. So it becomes 5 times n plus 2 plus 6. See, that went in place of the x. We can clean this up so that g of n plus 2 is equal to 5n plus 10 plus 6, or 5n plus 16. So what's the ordered pair? Well, the x we plugged in was n plus 2, and the result we got was 5n plus 16. So function notation, don't solve for the f, don't solve for the g, okay? This is our x, and this is our y value, or f of x. For the following functions, we're going to look at a couple representations of how to find f of 7. First one is what we just reviewed. F of 7 says if I plug in an x, what do I get? Well, negative 7 plus 2. So f of 7 is negative 5. What if they gave me a list of points and they said, what is f of 7? F is a collection of all these points. They want f of 7. If I look through here, I see 7 pop up twice. Which one do I want? Well, the 7 is the x value. So I want to know, basically, if I plug in a 7 for x, right? That's what this means. If I plug in a 7 for x, what y value do we get? Well, the y value there is 15. So f of 7 is 15. And that's the answer we're looking for. That is the y value, or the f of x. What if they gave me a sketch of numbers like this, and they said, what's f of 7? What is that 7? That is the x value. What goes over here is the y value that matches this x value. So what matches the 7 this time? 7 goes to 23. So f of 7 is 23. Do not solve for f. What if they give me a graph? Too far, too far, too far. Sorry about that. What if they give me a graph? F of 7 means what again? What y value matches that x value? So go over to the x value, 1, 2, 3, 4, 5, 6, 7. Go where x equals 7. Go up to that point, and it has a y value of 2. That is the y. F of 7 here is 2. How do I know? That point right there is 7, 2. The 7 is the x, the 2 is the y value, or the f of x. If y equals x squared minus 1, what is f of x? Well, we already said that y equals f of x, so that's easy. So f of x is just x squared minus 1. You replace the y with an f of x. What is f of negative 3? F of negative 3 means I go to my function notation and I plug that negative 3 in for x. So negative 3 squared minus 1. How about 9 minus 1? How about 8? So f of negative 3 is 8. What is f of n? Well, I'm going to put that n in place of all the x's. So what's going to happen this time? Instead of x squared, it's going to be, and that's it. You literally just plug whatever is inside there in place of the x. F of x is x squared minus 1. F of n is n squared minus 1. Whatever goes here replaces the x. So if it's a letter, we put the letter in there. What if x minus 5y equals 3? What is f of x? Well, we said we can replace y with f of x. Problem this time is it's not y equals yet. So we need to get y equals by subtracting the x. So how about negative 5y is equal to negative x plus 3. Dividing by negative 5. Each term gets divided by the negative 5. So that y is equal to positive 1/5 x minus 3/5. That's not our answer, right? They want to know what's f of x. Replace the y with an f of x so that f of x is 1x over 5 minus 3/5. Okay? So what is f of negative 3? Well, f of negative 3 means I'm now plugging a negative 3 in place of the x here. So it becomes negative 3/5 minus 3/5, negative 6/5. So we got negative 3, comma, negative 6/5. What is f of n? We're replacing it with an n, so 1x becomes 1n over 5 minus 3 over 5. And that's it. Can't simplify that any further, so that would be f of n. What if I asked you to graph it? Well, our y-intercept is negative 3/5. Not loving that. About negative 0.6. We could approximate that. And then our slope is 1 over 5. So from there we could go up 1 over 1, 2, 3, 4, 5. And I could get a rough sketch of this function. If you want to pick out a little more clear points, you could plug in some numbers that would make a nice clear point. For instance, like 3 should give us 3, 0. If you want to plug in some points, you get some whole numbers, and I think 8, 3, 4, 5, 6, 7, 8 gets us to 1. So obviously I need to make that a little wider, but anyway, you can plug in some points if you need it more clear. It's your call. All right, what is the domain? Well, this is a linear function, right? What is the domain of linear functions? How can I tell visually? Well, look, the graph goes left forever, the graph goes right forever. Therefore, negative infinity to infinity. What is the range? Well, the range of the y values goes up forever, down forever. So the range is also all real numbers, from down forever to up forever. And that's it for this section. Really, it's just kind of an expansion of 9.2. So let's get through those sections. We're almost ready for our next test.